find the extraneous root of the radical equation. So when we say extraneous root, this is actually a root, but it will not make the equation correct. So what we're going to do here is we are going to solve for x. We will write 3x plus 6 equals 1 minus root x plus 3. We square both sides, we will get 3x plus 6 equals, this becomes 1 minus 2 x plus 3, and then again plus x plus 3. We just combine like terms, we will get 3x plus 6 equals 4 plus x minus 2 root x plus 3. Then we combine everything on the other side of the equation. We will get, this becomes 2x, and this becomes plus 2. Then you will have negative 2 root x plus 3. We divide everything by 2, you will get x plus 1 equals x plus 3. That is negative, by the way. And then we square again. Both sides. So what's going to happen is this. We're going to get x squared plus 2x plus 1. That will give you x plus 3. X plus 3. Then we solve for x. So this becomes x squared plus x, and then minus 2 equals 0. So the factors of this one will be x plus 2, and then x minus 1. So x will be negative 2, and then x will be positive 1. So if we're going to simplify this one, if we're going to put back these numbers here, we will actually see that 2 will make it the same. This becomes 1 equals 1. But when you plug in 1 there, it will give you 5 equals 1. So our extraneous root will be x equals 1, or letter B. 192. Given a circle with radius 8, to find the length of the chord 4 units from the center. So what we're going to do here is draw first your circle. So example, this is your circle. And again, the radius is 8. Radius is 8. So therefore, the diameter is 16, right? This is 8 and 8. And then we have here a chord that is 4 units away from the center. So this is our chord. This is 4 units away. And we're actually asked to find how long, or the length of that chord. Just assume that my circle is perfect. So to find the length of this one, we can actually make use of the idea of the isosceles triangle. Because again, there is a triangle, right? So we can actually have this triangle. And this triangle is isosceles. This is 8. This is 8. And again, this is also 4, right? The height is 4. So what we can do is we can solve this one using the Pythagorean theorem, and then just multiply it by 2, because this part and this part are actually equal or the same. So since we have the hypotenuse 8, you're gonna get 8 squared minus 4 squared. That gives you 64, right? Minus 16. And this is actually 48, root 48. And root 48, this is just equal to, remember, 48 is equal to 16 times 3, right? So this is just 4 root 3. So if this is 4 root 3, what is 2 times 4 root 3? That is actually 8 root 3. That's letter B in the choices. Number 193. Chaz has 5 times as many chocolates as Zachary. After she gave 20 chocolates to Zachary, they have now equal numbers of chocolates. How many chocolates do they have altogether? So we have Chaz, C. She has 5 times as many chocolates as Zachary. So 5 times Zachary. After she gave 20 chocolates to Zachary, so we need to say, after she gave 5z minus 20, they have now equal number of chocolates. So this is equal to Zachary plus 20. And then the question is, how many chocolates do they have altogether? So we need to solve first for Zachary. And then after that, we need to solve for Chaz and then add together their chocolates. So this becomes, this is for Zachary equals 20. Transfer here, that becomes 40. So Zachary actually has 10 chocolates. So if Zachary has 10, Chaz will have 50, right? So the sum of their chocolates is actually 60. Number 194. The length of the rectangle is 3 units from its width, 3 units more than its width. So we have the length is equal to 3 units more than the width. So this is width times width plus 3. When the width is reduced by 25% and the length is increased by 3 units, the area of the area will be the same. Find the original dimension. So meaning to say the area of this first triangle, or the original triangle, will be length times width, right? But we know that length is W plus 3. So this is actually equal to W plus 3. Again, that is times the W. And then the second area, it says here, the second area, what happens? The width is reduced by 25%. So the width is reduced by 25% and the length is increased by 3. So if this is our length, it's increased by 3. So this is plus 3, right? So the width will be W plus 6 times the width is reduced by 25%. So that is 0.75 W. And then we just going to equate them because it says here the area will still be the same. So we will do, this is W squared, right? W squared plus 3W. This is equal to 0.75 W squared. My space is not spacing. And then we're gonna have, what is 6? 75% of 6. That is 4.5, right? So this is plus 4.5 W. And then we're just going to solve the quadratic equation. We're gonna get 25 W squared, right? And then this will be equal to, this is just W. So 4.5 W minus 3 W, that is 1.5 W. And then we forgot to factor out a W here. So we factor out W, divide everything by W. You're gonna get 0.25 W equals 1.5. And to solve for W, we will have 1.5 divided by 0.25. So our width is actually 6. So the width is 6. There's only one choices that has 6. That is letter C. Because again, that makes sense because 6 plus 3 is 9.